I'm assuming that you have watched the two videos that I already uploaded for you, the Tyler Dewitt videos that show you how to construct formulas for ionic compounds. If you haven't watched them already, I recommend going back, watching the two videos that are uploaded just above this video, and then coming back to this video. I'm going to mostly deal with examples in this video. Okay, here's the summary. If you have an ionic compound, how do you recognize an ionic compound? It has a metal. Recall, ionic compounds are made out of ions. So when you write the formula, you have to balance the positive and negative charges. So here's an example. Let's say your cation A contains one positive charge, and your anion B has two negative charge. Now, if I just take one of each, there is only one positive charge, but two negative charges. So if I combine them, you don't get a neutral compound. Compound must be neutral. That means the number of positive and negative charges must be equal. So if I take two A's, if I take two of these A's, now I have equal positive and negative charges. I have two positives, and then here you have two negative. So you write the formula as A2, since we have two A's, the number 2 goes as a subscript. And we have one B, so that B will be only 1 in the formula. You can actually drop that 1. It's dropped when you write the formula. So A2B will be the formula of this compound. So an ionic compound containing A positive, B2 negative will be A2B. For every one B, you will have two A's in that compound. Okay? You can also see this by a crisscross method. So if you have A plus and B2 negative, if you crisscross, the charge plus becomes the subscript for B. The charge 2, negative 2, becomes the subscript for A. If you chose to do this method, make sure you simplify it, because sometimes, let's say you got 2 to 2. That should be simplified to 1 to 1. So here we have 2 to 1. It's already simplified. So we can see how the formula is A to B. So you can also use this crisscross method. Suppose A is a polyatomic ion. Let's say you have, instead of A, you have Ca. Okay, so this is a group of ions. It's a polyatomic ion carrying a positive charge. Okay, so now how does the formula change? Again, you need two of them for every one B. So this time, instead of A, you have Ca. And Ca is polyatomic, and you need two of them. You need a parenthesis here. If you don't put the parentheses, then it is telling you that you only have two A, but only one C. Okay? Two CAs means two C's and two A's. So you need a parenthesis and then the two outside the parentheses. Now when you name the ionic compounds, this is very important. When you name the ionic compounds, you just put the cation name followed by the anion name. For example, if I have, let's say I have magnesium, let's say I have Cl2, okay? So you know that it's an ionic compound because it contains a metal. So you have to just name the cation. So cation name will be just magnesium. You don't have to say magnesium ion, just say magnesium cation. And then anion name will be chloride. Recall that Cl negative was called chloride ion. This is chloride ion. This is chloride. So our anion name is chloride, so this is just magnesium chloride. Suppose you had MgClO3 twice. Again, your cation is magnesium, but the anion is chlorate. ClO3 negative is chlorate. Okay, you can look up all your polyatomic ions, you can write them somewhere and look up where you see ClO3. You will see that ClO3 negative is called chlorate. Chlorate. Most of the confusion comes how you end the name. just if you just have monoatomic ions, this is just chlorine, right? So it ends with chloride. We learned about monoatomic ions in the lecture 2, the last video. You get them from the periodic table, and the name ends with "ide." ClO3 negative is called chlorate. So that's what you do for ionic and ionic compounds. Now coming to molecular compounds, how you identify them is that they contain only nonmetals. And specifically, we are going to look at only binary molecular compounds. That means you have only two different elements. Examples would be CO2, PCl5, H2O, okay? These have only two elements in them. So we are going to deal with only such binary molecular compounds. Now, when you name them or when you write the formulas, you use prefixes. This is very important, guys. Molecular compounds, the nomenclature uses prefixes. So suppose you have the name, let's say carbon tetrachloride. Okay, it's made out of carbon, which is a nonmetal, chloride, which is a nonmetal. So obviously this is a molecular compound, and since this you saw a prefix tetra here, you should automatically conclude that this is a molecular compound. So carbon tetrachloride will be carbon. Tetra means 4, so this is telling you that you have 4 chlorides. So CCl4 is going to be its formula. So how would you name, for example, see that the name is ending with "ide." So you use prefixes and the name ends with "ide." So for example, if you have, let's say N2O5. So let's go back a little. So let's say you have N2O5. How will you name this? You have 2 nitrogens, so while naming also you have to use prefixes. So you can say dinitrogen because you have 2 nitrogens. This is dinitrogen. 5 oxygens, so it's going to be pentoxide. Instead of calling it pentaoxide, that naming sounds weird, we drop the A. We just say pentoxide. Okay. Suppose you have, this compound, CO2. This is again a molecular compound because it contains only nonmetals. So how would you name it? You have only 1 carbon, so it's mono, but mono is dropped if it comes at the very beginning of a name. So we can drop the mono, we can just say carbon. We have 2 oxygens, so it's going to be di. The name should end with "ide," like I said here. It's going to be dioxide. Okay. What about CO? How will you name this compound? Again, instead of saying monocarbon, we drop the mono if it comes at the very beginning with the first element. Okay. So instead of saying monocarbon, we just say carbon. For the second element, again, this is 1, mono, but since it is in between, you should not drop it. Mono is dropped only at the very beginning. So you're going to say carbon monoxide. Carbon monoxide. And you may be familiar with these 2 compounds, but you can see how this is named. These molecular compounds are named according to prefixes. So remember, prefixes are used for molecular compounds. The name ends with "ide. Mono is dropped only at the very beginning of the name of molecular compound. Here are some examples. Silver nitride. So this doesn't contain any prefixes, so obviously this is an ionic compound. Also we have a metal here. So what's the formula for silver ion? If you look at the periodic table, silver is a transition metal. So usually the name of this should have come with a charge. There should have been a charge specified in the parentheses. But silver, zinc, and cadmium are exceptions. We talked about this in lecture 2 last video. Silver is always plus, zinc ion is always 2 plus, so cadmium is always 2 plus. So instead of saying silver 1, you could just say silver ion. It's always understood that silver ion is plus 1. So silver is Ag plus ion. And nitride, it's ending with "ide" and looks like it's monoatomic because there is only nitrogen in the name, okay? It's ending with "ide." That's the key. It's ending with "ide." That means it's monoatomic, means I have to look up the periodic table to determine the charge of nitride. Nitrogen is in this group here, sixth group. So the group numbers are 1, 2, 3, 4, 5, 6, 7, 8. Nitrogen is in the fifth group, and you can see it is 1, 2, 3 away from the noble gases. So it's going to accept 3 electrons. Another way to do it is just for the nonmetals, you can do 5 minus 8. So you can see how far it is from 8, and that's -3. So the charge of nitride is -3. So the charge is -3. Let me go ahead and write the charges. +1, +2, aluminum +3, -1, -2, -3. Since nitride has -3, nitride is -3. So now we can crisscross the ions. So 3 becomes the subscript here, 1 becomes the subscript there, 3 to 1. And this is already simplified. So we can say silver nitride will be Ag3N. Do not write the charges on this compound after you have determined how many silvers and how many nitrogens you need. Next example, copper 2 chlorate. The copper 2, the 2 here is the charge of copper. Since copper is one of those transition elements, it comes with variable charges, and the charge is specified here for you. So we are dealing with a copper 2 plus ion. Chlorate, it's ending with 8, so it's not something you can determine from the periodic table. This anion is a polyatomic anion, and you should have memorized this list. So chlorate is ClO3 negative. So chlorate is ClO3 negative. So crisscross the charges. So 1 negative becomes 1 as 1 is the subscript now. 2 positive, this becomes the subscript for chlorate. And make sure you simplify this. 1 to 2. That's already in a simple ratio. So you need 1 copper and 2 chlorates. Since this is polyatomic, we put a parenthesis and then put the 2 outside. So this is copper 2 chlorate. Let's keep going. Aluminum. Aluminum ion's charge is always +3. So we have aluminum ion. And sulfide, if the name ends with sulfide, ends with ide, you go to the periodic table to figure out the charge. So sulfide is sulfur with 2 negative charges. Sulfur with 2 negative charges. Crisscross, 2 to 3, and that's already a simple ratio. So it's going to be Al2S3. Okay. Copper 2 chlorite. So copper is 2 plus. So copper 2 plus. Chlorite is ClO, it's ending with ite. Ites are 1 less than 8s. So if chlorate is ClO3 negative, chlorite will be ClO2 negative. Okay? So now do the crisscross. So 1 becomes the subscript here, 2 becomes the subscript for chlorite. So that's going to be copper 1, so Cu1, and chlorite 2 of them, so ClO2 twice. So that's copper 2 chlorite. Ammonium hydroxide. Ammonium is NH4 plus. It's one of the polyatomic ions you have to memorize. Hydroxide, this is also a polyatomic ion you have to memorize. This one, even though it has it's ending with ide, it has hydrogen and oxygen in the name. So this is polyatomic. So it's one of those that you have to memorize. So ammonium hydroxide will be, so if you crisscross, it's just 1 to 1. So ammonium, 1 ammonium, and 1 hydroxide. Okay. All right. What would be, let's say, magnesium oxide? Magnesium oxide. Magnesium ion. Magnesium is in the second group, so it's always +2. Magnesium's charge is always +2. Oxide, name is ending with "ide", so it's O2 negative. O2 negative. This time, let's say you're choosing to do crisscross. Okay. In that case, when you simplify, the 2 becomes the subscript 2 there. The 2 here becomes subscript 2 there. So 2 to 2 can further be simplified to 1 to 1. Okay, so you need 1 of each, 1 magnesium and 1 oxygen. And now you can see that clearly since you have 2 positive and 2 negative. If you take just 1 of each, the charges will balance. Okay, so magnesium oxide is MgO. You take magnesium and oxygen in the ratio of 1 to 1 in this compound. Okay, that's what the compound has, magnesium and oxygen ions in 1 to 1 ratio. Now coming to naming these compounds. So we have names here. Here, when you name, it's very important to see whether the compound is ionic or molecular. So this one, ammonium chloride. Ammonium chloride is the only exception you have to remember. Ammonium chloride, this is an exception. That means though it doesn't contain a metal, it is still an ionic compound. It's an ionic compound, even though it doesn't contain a metal. Okay. So name the cation. Cation is ammonium, as you can see here. NH4 would be ammonium with a positive charge. This is a compound. You should understand that this is positively charged within the compound. The charges are not specified when you write the compounds, but you have to understand that it's carrying a positive charge. So that is ammonium. So write cation name first, followed by the anion name. So ammonium, and then Cl. This is monoatomic. It's not ClO3 or it's not ClO2. It is just Cl, right? It doesn't contain any other element. It's just chlorine element. So it's monoatomic. So it will be named chloride. So all these with the charges, they are named with ides. The name ends with ide. So it's ammonium chloride. So this would be calcium ion. So we can just say calcium. We actually don't need this 2 there. Okay, because calcium is always 2 positive. So it's understood. So you don't need a parenthesis here. Calcium is in the second group. Its charge is always, calcium ion's charge is always +2. So calcium and NO2. This parenthesis 2 is just telling you that you have 2 of those. You have 2 nitrates with some charge. There is some charge on them. Okay, and if you look up your memorized ions, nitrate, NO3 negative is nitrate. So if you decrease 1 oxygen, NO2 negative will be called nitrite. It ends with ite. 1 oxygen less than 8 is ite. So you're dealing with, it's NO2 negative. You're dealing with NO2 negatives here. You have 2 of them, but you just write the cation name followed by the anion name. So this is going to be calcium nitrite. Next one, this 5 should have been a subscript. Okay, V2O5. Okay, so V is vanadium. V stands for vanadium. And this is a transition metal, so you have to write it along with its charge. So it's vanadium. And I'm going to figure out its charge and put it as a Roman numeral. And you have oxygen. That means this, you have an oxide ion. You have 5 of those, okay? Oxide is oxygen with 2 negative, and you have 5 of those in the formula. So this is just telling you, if I split it up for you, you have 2 vanadiums with some charge. I'm going to call it X positive. Metals always form cations. And you have 5 oxygens with charges, with their respective charges. And oxygen, you know, will form 2 negative charge. So oxide is 2, this is 2 negative. This is what you have. Okay? So cation name is vanadium with whatever the charge is, and the anion name is oxide. So this is oxide, vanadium charge oxide. So what is the charge on vanadium? So you have a total of 5 times 2, that is 10 negative charges. So you should have 10 positive charges as well. That means on each vanadium, you should have a 5 plus. Okay, so you're dealing with vanadium with a 5 plus charge. Since vanadium has 5 plus charge in this compound, this is a vanadium 5 oxide. Okay, this is vanadium 5 oxide. Another way to think is to crisscross, but you have to be very careful when you do that. So vanadium is getting 5 plus and oxygen is 2 negative. You have to make sure this is working. You have to go back and make sure that oxygen is in fact 2 negative, and this is correct, because sometimes the crisscross doesn't work because these are in simplified ratio. They may not be the charges themselves. They may be, these subscripts may have come after simplification. So when you crisscross, you have to make sure that they're making sense. If you crisscross, oxygen is getting 2 negative, and that makes sense. So vanadium getting 5 positive will also make sense. Okay, here we have CO. CO stands for cobalt. This is one of those you should have memorized, the symbol. Everything in these 2 and these 6 groups and this row of the periodic table, you should know the names, because the periodic table that will be provided on the exam may not contain the name, so it's good if you know them. So cobalt. And since it's a transition metal, we need parentheses with the charge. And CO3. We're dealing with a carbonate. So carbonate is the anion. So carbonate. So think about it. What is the charge of carbonate? Carbonate is 2 negative. So cobalt here should have been 2 positive. So it's 2, cobalt 2, carbonate. As you can see, the crisscross is not working. Crisscross would have given you 1 and 1. But carbonate doesn't have 1 negative. Carbonate's charge is 2 negative. So crisscrossing wouldn't have helped you there. So you have to determine the charges. That's the method that will always work. So here you have copper 2 SO4. SO4 is sulfate. So I know my anion is sulfate. My cation is copper. What is the charge? Sulfate is 2 negative. You can go back and check. Sulfate is 2 negative. Okay. That means, so since I have 1 sulfate in this compound, and we know its charge is 2 negative, you have 2 coppers in this compound. What should be the charge on each? Positive and positive, because since you have 2 negatives, you need 2 positives from 2 coppers. So each one should have 1 positive. So since the copper ion has a positive charge in this compound, it is copper 1 sulfate. Okay? All right. Now here's another example. PCl3, AlCl3. Don't forget, this is molecular. So every time you do the naming, think about whether it's molecular or ionic. This is molecular, so we use prefixes. So we just write the name phosphorus trichloride. The second example here, this is ionic. And in ionic compounds, we don't use prefixes like tri. We just write the cation name followed by the anion name. Okay, so cation is aluminum. And then anion is chloride. So this is just aluminum chloride. We don't need the tri there because this is an ionic compound. All right, hope this makes sense. Take your worksheet too and try to work the naming and formula writing by yourself. You have to show your work on the worksheet, all the crisscrossing ions, writing your cation, writing your anion. So keep practicing. You'll get better at it as you do more problems.